When you're trying to convert a repeating decimal to a fraction, it's really helpful if you know a couple of kind of tricks, okay? For instance, if you watched the video about converting the terminating decimals to fractions, you knew that you would just look at the value where the last digit is, and you would use that place value. So in this case, this would be the tens place, right? It would be 7 over 10. But the problem is that this is a repeating 7. So it's not just 0.7 and then it ends. It's 0.7777 for all of eternity. But there is a convenient little rule for that. And that is whenever you have a single digit that's repeating, it's always that number over 9. So 0.7 repeating is literally just 7 9s. And if you know that little trick, that's pretty quick and easy. 0.1 repeating, since it's one digit repeating over and over, would be 1/9, okay? 0.27 repeating, now this is a trickier one because it's two digits repeating, and there is a rule for that. I'm going to talk about more when we get to all of these ones down here. Again, if you've watched my videos before, you'll know that if you have two digits that are a multiple of 9, which 27 is, that this will have a denominator of 11 when it's reduced all the way. And you would just ask yourself, well, what times 9 equals 27? 3. And that means that this is going to be 3 11s. And again, if you haven't seen that other video, that might not have made too much sense. But stick with me because once I teach you the other trick, you'll be able to get to 3 11s pretty easily there. 1.5 repeating. So this 1 tells me that I have one whole number, and then 0.5 repeating, since it's one digit repeating, it's just 5 over 9. Over here, I have a -3 whole number. 0.6 repeating would mean it'll be 6 over 9. And remember, if you can reduce, you should reduce. 6 over 9 reduces to 2/3. So this would be -3 and 2/3. Okay, so first simple rule is simply that if it's just one digit repeating, it's that number over 9. For a two-digit repeating number, okay, if this was a terminating number, it would be 48 over 100. But since it's a repeating two-digit number, it's going to be 48 over 99. Okay, so two-digit repeating numbers are always over 99. 0.95 repeating is 95 over 99. Okay, 0.09 repeating. Okay, 09 is just the number 9, so it's 9 over 99. Don't get confused thinking this is just 9 over a regular 9 because it goes to the second decimal place here. So there's two numbers here, which means it's over 99. And just keep in mind, again, 9 over 99 can be reduced to 1/11. Okay? This is why up here I end up with 3 11s, by the way. 27 over 99 is the same thing as 3 11s when I reduce it. Okay, it's just, like I said, if you had that other trick already in your back pocket, it was kind of a quick way to just get straight to 3 11s. Okay, so what if you have a whole number or even a negative whole number? It's fine, it's going to be the whole number in your fraction. And 28 over 99, because it's a repeating decimal. Same thing here, 7 is our whole number, and this will be 83 over 99 because it's repeating. Okay, so one digit repeating means it's going to end in, the denominator will be 9. Two digits repeating means the denominator will be 99. Three digits repeating, guess what? I think you guessed it. It'll be over 999. 61 over 999. You got to watch out for that. Okay, you can put 061, I guess, but that's not technically how we would write the number 61. 207 over 99. I'm sorry, 999. This is just 6 over 999. All those zeros right here pushed it to the 999ths. And then 583 over 999. Now, I'm sure some of these can be simplified, but we're not going to focus on that in this video. Okay, so far we have just a little trick to help you with the repeating decimals, turning them into fractions. As long as you have a one-digit repeat, two-digit repeat, three-digit repeat, I mean, even if you have four-digit repeats, you would just do the number over 9,999. You could keep going from there. That works really well when you've got just the whole thing after the decimal is being repeated. But where it gets confusing and where you have to have a little bit of an extra trick up your sleeve is when you get a number like this. Okay, so this is different because the 1 is not repeating. The 2, 3 is repeating. This is really going to look like this. 1, 2, 3, 2, 3, 2, 3, 2, 3, forever and ever and ever and ever. Okay, so that 1 does not repeat. So you can't use the rule of 9 or 99 or 999 for this. It's just not going to work. So I'm going to explain how this works. It is tricky, I'm not going to lie to you. It really involves having a good idea of how equations work and how algebra in general works, because we're going to create some equations here and then manipulate the equations in order to get a fraction. So the first thing I do is I take this and I expand it out like this, because my brain works a little bit better when I can visually see, oh, there's a lot of 2s and 3s here. Only the 1 gets to stay by itself though. And I take that and I make it an equation where it says x equals that. Okay. Now I'm going to make a second equation, and it's going to be equivalent to this equation, but I'm going to multiply both sides by 100. Okay, so if I take x and multiply it by 100, I get 100x. Agreed? X times 100 is 100. So I'm just taking this equation and multiplying by 100. Now, if I take this side and multiply by 100, a lot of you understand that multiplying by 100 just means that the decimal place gets moved 2 places. Okay, and if you don't quite understand that, I can show you on a calculator how that's true. Okay, it's gonna be a little weird because I can't actually put in 2, 3, 2, 3, 2, 3, 2, 3, 2, 3 forever and ever, okay? But if I multiply it by 100, you see how the decimal point just moved from in front of, oh, you can't even see it. If you multiply it, instead of 0.12, the decimal place moves in 2 spaces, so now it's 12.32323232, okay? So it moves the decimal point in 2 spaces. So I get 12 point, and then starting from here, the numbers keep repeating. And I like to do a bunch of them. Like I said, it helps my brain. So I have 2 equations here, okay? I have my original equation, which was just the number that I'm trying to convert to a fraction, and I put an x equals in front of it. Okay, so now I have 2 sides of the equation. And then I took that equation, I multiplied both sides by 100, which I'm allowed to do. In algebra, you can do whatever you want to both sides as long as you do it to both sides. I multiplied both sides by 100, so it's the same. I am now going to take this equation, and I'm going to write this first equation underneath it. Okay, x equals, and I got to line up my decimal points, okay? So 0.123, so 0.12322, dot, 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 basically like that, okay? I'm going to subtract the 2 equations from each other. I'm allowed to do that, by the way. I can take 2 equivalent fractions, and if I add them together or subtract them from each other, I get a third equivalent equation. That's kind of a little nifty trick in algebra. If I subtract here, I'm going to use a different color pen here, 100x minus 1x gives me 99x. Now here's where what we just did previously helps us out, because you can see my dot, dot, dots mean that it's going to go 2, 3, 2, 3 forever, whatever. Those 2s and 3s are all going to cancel out to 0, because when I subtract 2 minus 2, I get 0. 3 minus 3, 0. 2 minus 2, 0. 3 minus 3, 0. 2 minus 2, 0. All the way up to here, this is the first time I actually get some real numbers. So I can cross out everything from here on forever and ever, and I just eliminated all those repeating parts, so that I'm left with 12.3 minus 0.1, which is going to be a terminating decimal. 3 minus 1 is 2. Drop the decimal point. 12 minus nothing is still 12. And look at this. I am left with 99x equals 12.2. I want x by itself, so I'm going to divide 99 from both sides. When I do that, x is left by itself, and I get 12.2 divided by 99. Look, I have a fraction now. Before, x equaled 0.1232323, repeating forever and ever. Now x equals 12.2 over 99. I have turned it into a fraction. Okay, and all I did was use the rules of algebra that state, do something to one side, you have to do it to the other side. If I add or subtract equations that are equivalent from each other, I get a third equivalent equation, and that helped me end up with a fraction. Now, just so you know, you're not supposed to have decimals in fractions. What we would do to clear that decimal out, we would say, you know what, if I multiply 12.2 times 10, that will move the decimal point over one spot, and I'll have 122 instead. Okay, so 10, obviously, since it's a fraction, they're stuck together, I have to multiply both parts by 10. 99 times 10 becomes 990. All I did was I scaled up this fraction, so it's an equivalent fraction, it's just bigger looking, 122 over 990. Now, this can be simplified. 122 obviously can be divided by 2, so can 990, but I'm not going to focus on that part right now. Okay, if you want to, you can reduce the fraction, but I'm going to leave it there for right now, and we're going to try another one here. Let's say we have 0.164 repeating. Okay, so again, it's not like these ones up here where all the digits repeat. There is a number out front that doesn't repeat. Okay, so first thing I do is I make an equation that says x equals, okay, the mystery number equals, and then I expand this out so that my brain can more easily see what's going on here. And I can see there's just a 1 and then 64, 64, 64. Second step was I made a second equation, an equivalent equation, and I multiplied both sides by 100. So x turned into 100x. This side, the decimal point just gets moved in 2 spaces when I multiply by 100. So I get 16.464644 forever and ever and ever. I find that it helps to kind of write out your numbers kind of spaced out really well. That helps in the subtraction later on. Okay, so I'm going to take this equation and subtract the original. Okay, so take x equals, remember you have to line up your decimal point, 0.164646, ... We're going to subtract everything. 100x minus 1x is 99x. You can see from here on, all of these line up perfectly, and so they're all going to just subtract down to 0, so I can just get rid of them. 4 minus 1 is 3. 16 minus nothing is 16. Last step would be to divide by 99. So x would equal 16.3 over 99. And because we're not supposed to have a decimal in our fractions, we would multiply by 10 over 10. So I would get 163 over 990. Okay? I'm going to do one more because I want to show you that there are times where you don't have to multiply by 100. Let's see if I'll have enough space on this paper here. For instance, if my number that I'm trying to change to a fraction only has one repeating decimal, okay? So the 8 doesn't repeat, but the 3 does. In that case, okay, I'm going to expand that out to show that the 3 gets, goes over and over and over. Instead of multiplying by 100 on both sides, I could just get away with multiplying by 10 because I just need to move the decimal point in one spot. So if I multiply by 10 on both sides, okay, and then I subtract this first guy, because I just have the 3's to worry about, the 3's are all going to line up. The reason I had to multiply by 100 in these other problems is because if I only multiplied by 10, then when the decimals, when we move them in, all my decimals would be off. So like the 6's up here would match the 4's down here. And the 4's up here would match the 6's down here, and I wouldn't actually be able to subtract them out. So you got to make sure that whatever you're multiplying by, because you can multiply by 10 or 100 or 1,000 or 10,000, depending on how big these numbers get or how crazy these numbers get, you just have to make sure that when you go to subtract, that the numbers do line up so that they will cancel each other out. If you did it incorrectly and multiplied by the wrong power of 10, you would be able to tell very quickly that they wouldn't line up and you wouldn't be able to subtract them. So it's not the end of the world. It just takes a little bit of extra time. Okay, so going back to here. So here, all we did was multiply by 10 instead. So 10x minus 1x is 9x. Over here, All those 3's are going to cancel each other out. 3 minus 8, I have to borrow. So I get 13 minus 8, which is 5. And 7 minus nothing is 7. So 9x equals 7.5. Oops, divide by 9 at the edge of my paper here. So x will equal 7.5 over 9. And again, because we can't have a decimal in our fraction, if I need to move this decimal over one space, that's moving it over a 10. So 7.5 times 10 becomes 75. 9 times 10 becomes 90. And again, you can reduce it from here, right? I can divide by 5s out of both of these and get a smaller number. So that's that. Repeating decimals to fractions, they're a little bit more complicated. Just to recap, if all the numbers are repeating, and I don't mean the whole numbers, all the numbers to the right of the decimal point, if all those numbers are repeating, it's pretty easy if you just know the rule that a 1-digit repeat is over 9, a 2-digit repeat is over 99, a 3-digit repeat is over 999, and so on and so on and so on. The problem is when you get numbers like this where there's something that doesn't repeat and then the rest of it does. Okay, and you could even have other numbers like 0.26, 54, 54, 54, 54. Like there could be 2 numbers here before the repeat starts. You could have 3 numbers here before the repeat starts. But in all of those situations, you can still do it this exact same way. You take your equation, you multiply. Usually multiplying by 100 works. Sometimes multiplying by 10 works. But what matters is that when you get to this part when you're subtracting, you get the numbers lined up so that they will cancel each other out. And if your numbers don't line up, you should try multiplying by a different number. Okay, instead of 100, multiply by 1,000 or multiply by 10. See if that works, okay? And then when you get to the end, remember that you can't leave decimals inside your fractions, so you do need to scale it up. Okay, scaling it up just means taking your fraction and multiplying it by 10 over 10 or 100 over 100 or 100 over 100, whatever you need to do, or 1,000 over 1,000, sorry, to clear out those decimals. And you end up with bigger numbers, and that's kind of annoying. And then you have to reduce the fractions, which is even more annoying. But that is the quickest way to get yourself a fraction when you've got a decimal like that.